My story is about creativity, specifically about how creativity in one area has inspired and ignited creativity in several other areas. And when we think about creativity, we think about minds that are very vibrant, have a lot of new ideas, want to create, and want to invent new stuff. Really happy campers. They love what they do, they like what they do. But soon, they come across practical realities. Your cost cannot be high of your design. It needs to be assembled very properly. You have to make sure that you cannot make multiple copies. You have to customize. You box them into stuff which makes them very unhappy campers. Now, what happens with that is they start off with a vision to develop something which is grand, which is out of the world, something like a bike, which you see there. And you end up with a bike which is extremely, extremely ugly. And the reason is manufacturing constraints. You start with a chair, and you end up with a folding chair. The question is why? Why does this happen? And the core of the problem is, if you look at all manufacturing technologies, traditional manufacturing technologies, they are essentially subtractive manufacturing technologies, where you take a chunk of raw material, you remove what you don't need, and you're left with the part that you need. There are two issues with that. One is you have to specify every surface mathematically, and you cannot remove what you can't reach into. And as a result, if you take any of our existing technologies, if you cut, bend, cast, manufacture, they all have the same problem, is you cannot build geometries which you cannot define. So what happened is, we saw this trend about 2 decades ago, and we decided to kind of change the way manufacturing was done. And a bunch of us got together and started working on an additive process instead. And the way an additive process works is you have 3 goals. One is you should be able to build any surface without any problems. You should be able to build multiple copies at the same time. With CNC, you can only build one part at a time. And there should be no waste. And what that led to is we invented 3D printing. And instead of manufacturing products and objects, what we do is we just print the object. And it could be any design, it could be any shape, and there is nothing required. So for example, a ball. It's a simple print head which jets out solid material and layer by layer builds an object from scratch. And here's a ball that was built using an inkjet printer. You make the layers thin enough, they stick to each other, and you build up a ball that bounces just like any other ball. And that way, you don't have to define every geometry that's on the object, and you give the creative people the freedom that they need to design and create what they want to design and create. Now, as we created more and more materials which could use this, and we had a lot of people really embrace this freedom of design. And what that led to is their story from here on. What you're going to see from here on is really their ideas, their creativity, and their inspiration. So the most obvious choice for people was to build objects they couldn't build before. These were geometries, optical illusions that people just couldn't build before, and now you could just design it in CAD, hook up a printer to it, and say print, and you could print objects which you couldn't build before. It completely changed the way people looked at manufacturing. The other use that people saw in this technology was form fit verification. They would build parts, bolt them into their assemblies, run fuel through it, run their assembly, and make sure the design works before they spend expensive money on tooling and other methods of manufacturing. So these two were kind of the most obvious choices for using the technology. Then came toys and figurines. And the most important part here was each toy was customized. Now there was a way for people to customize each and every toy that they could make. Printing your own statue, printing your own bust is very inexpensive now. All you got to do is scan yourself and you print yourself. And there was an example on the screen. And these were some of the ways people expressed their creativity once they got our technology. As time progressed, we got requests for one-of-a-kind parts at extremely low cost. Architectural models, they build only one of those. They build with cardboard. Instead now, they just print the models on our systems, on our printers, and you get one model anytime you want. You want to make design iterations, you make it on CAD, and you print another model again. Very easy to do. In a span of 2 to 3 years, we completely revolutionized the jewelry industry. All jewelry patterns now are manufactured using 3D printers. The way they embraced this technology was just phenomenal. What they did was, they could make any design now, they could make it at low cost, and they could make it as accurate as possible. And a plaque of multiple jewelry items could be each customized and different and built in one shot. All of you artists out there, lampshades, chairs, furniture, artistic pieces, you can print one-of-a-kind boutique pieces which can now be sold at much higher prices and make a great business out of it. It all can be printed without having to do any kind of manufacturing. And the creativity just completely exploded over the period of last 10, 15 years. The medical people didn't want to be left behind. So what they did is now is they take CAT scan and MRI data, they print the model of a patient, they practice the surgery on the model before they actually go and operate the patient. Success rate increased phenomenally. Fetus verification, you can build models of fetus, you can have body implants built which go inside the body. It completely changed the medical industry on how it operates today. Now the biggest opportunity, this was all nice and fine. The biggest opportunity that people found is mass customization. The body implants were kind of the starting of mass customization. But what mass customization really was is every person sitting here is different. And every person has a different physical need. An example is hearing aids. Each hearing aid you see on that plaque today is for a different patient, and 100 hearing aids are printed in 1 hour. Initially, it used to be that one hearing aid could be manufactured in about 1 hour because it was an artistic industry. Invisible braces, for those who have used it, all these braces are scanned using the mouth and then printed using 3D printing. As a result, what has happened is something that was really painful has been converted into a very easy process. For those of you who have bridge and copings done, all dental models are now being built on 3D printing. The goop that they put in your mouth is soon going to be history. And they have embraced this technology very quickly. The future is here, real body parts. In about 20 to 30 years, we will print real organs that can go inside people's bodies. Today, there is research being done where we can print bone scaffoldings, we can print tissues, we can print skin. But in 20 to 30 years, the goal is to print organs. So I'll just leave you with one thought, is if somebody ever tells you that you can't put a square peg in a round hole, just sit back and say, let me try it, because I think it can be done. And if you want the answer on how to do that, just find me, I'll be around here, and I'll tell you how to plug a square plug in a round hole. Thank you.
Way to go.